Yes, hello children, how are you all? Now it's time for us to get into the details of something very essential in what is called separation of mixtures. So we have learned in detail about each of those different types of separation of mixtures. Now, in that we have learned of one type called as the distillation process. Now we also have discussed a little about distillation process that is involved in separation of gases from air. Okay, right. Now let us get into the details of separation of gases from air by what is called as distillation or fractional distillation of air. Now, okay, children, the main idea behind this is we have to convert air into liquid, and we allow liquid to get hotter. As it becomes hotter, the different gases which have different boiling points, they will gradually separate out at different temperatures, and they will be separated. Okay, so this is the main idea behind separation of the components of air by what is called as fractional distillation of air. So the process involved is fractional distillation. So let us get into the details of separation of the components of air by fractional distillation. Now, so okay, right. So what is the thing that you observe? The first part that you see here is this is the diagram, children, that represents the process, actual process. It's a very big process, the tedious process, I should say, and it requires a large, big, very big plant, industrial plant to do all this work, right? So now, what is the first thing that we see in this? The first thing that we see in this is the air from outside is passed through filters and into a chamber, and the filters, what do? They filter the dust. That dust, when it's filtered out, will now the dust-free air that gets into what we see here, that is the next chamber, which is a chamber in which the air will be compressed and under very high pressure of approximately 200 atmosphere pressure, right? Okay, so you know well what 1 atmosphere pressure is. So that will be around 76 centimeters of mercury. So that is what is the atmospheric pressure. So 100 kilopascal, right? So 200 atmosphere of pressure is applied on air. So due to that high compression, the air in that compression chamber, it becomes very hot. It becomes very hot and gets compressed. So right, now this compressed air is allowed into the next chamber, that is called as the freezing chamber. And in this chamber, as you can see, there are some pipes, and through these pipes very cold freezing water is sent, or coolant. It acts as a coolant. So as the hot air is getting in, what happens is this water, it cools, and as this compressed air is becoming free or expands, what happens is when air expands like this, it gets cooler. Okay, right. So as it gets cooler by what we call adiabatic expansion, so result is the temperature gradually decreases. That happens many times. So the cold air, as it is moving up, trying to move up, so the hot air it meets, and gradually for more number of time, as time passes, the temperature inside it becomes minus 200 degrees Celsius. Okay, and during this process, what happens is the water which is there as moisture in air gets condensed as water, and that water will be absorbed by absorbing filters. Okay, now this air, which is very compressed and highly compressed and cool, that will be sent into the next chamber called the separator. So you can see, children, that is a separator chamber, and that separator chamber, in that separator chamber, now the cold compressed air will be allowed to expand. So as it expands, so what happens, children? It comes to a temperature of minus 79 degrees Celsius. Now, okay, children, when it comes to minus 79 degrees Celsius, what happens is the the what do you call this carbon dioxide, it becomes what do you call it's actually the boiling point of carbon dioxide is minus 79 degrees Celsius. During that time, as it is undergoing what is called as expansion, it gets suddenly cooled and becomes dry ice, and that gets separated. So carbon dioxide now will not hinder the process of separation of the other gases in the air, that is oxygen, nitrogen and argon and a few other gases. So carbon dioxide is separated as dry ice. Good. Next, what is done to this air? Now this after passing through the separation tank, that compressed air from which the carbon dioxide gas is removed, it is passed through a jet, as a jet, and jet when the cold compressed air goes out through the jet, it suddenly expands and forms a liquid by what is called Joule-Thomson effect. And when it becomes a liquid, this liquid air is sent into the other process, the last process you can say, that is the fractionating column. And when it enters the fractionating column, so there now the temperature, so in that the chamber in which there is a liquid, the temperature is again minus 200 degrees Celsius, where the whole thing is as a liquid. Now, so when it gets into the fractionating column, so there the temperature will rise. Now, how will it rise? Now, after minus 200, what is the next temperature, children? So it will be minus 199. Minus 199, for your information, is greater than minus 200. Can you tell why? Yes, in integers, the greater the absolute value of a number, that is smaller. Okay, right, and the lesser the absolute value of a number, then that is greater. So minus 200 is lesser, minus 199 is greater temperature. So gradually the air which is in the liquid, it is allowed to increase its temperature. As the temperature increases to minus 199, the next minus 198, the next minus 197, and next coming to minus 196. Now when it comes to minus 196, the temperature remains constant there. And do you know what happens, children? For some time, the reason is at that point the nitrogen gas is boiled off and that is settling or separated as a separated gas. Now, so all nitrogen gas is separated from liquid. Now there are two gases and a few gases like oxygen and argon, apart from a very fine percentage of the other inert gases. Now what happens next? Right, okay, now it reached minus 196. At that point nitrogen gas has just got vaporized. Okay, it has become gas and it is separated. Now the temperature rises again. As the temperature rises to minus 195 and the next minus 194, and when it comes to minus 186, which is the boiling point of argon, what happens is at minus 186 temperature or degree Celsius temperature, what happens is argon just starts becoming a gas, and that will be separated. Why does it become a gas there? Because the boiling point of argon is minus 186 degrees Celsius. Now you know very well, children, for your information, boiling point doesn't mean that it is liquid becoming gas. Okay, gas also becomes liquid at the same temperature. That's an extra information which you have learnt in states of matter and transition of matter in chapter 1. Okay, good. Right, okay, at minus 186 degrees Celsius, argon gas, which is an inert gas, it goes out. So children, so what have we separated now? We have separated one, what is that? Nitrogen gas got separated minus 196 degrees Celsius. Then next we separated at minus 186 degrees Celsius. Argon gas got separated by fractionation, and what remains last is your oxygen. So this oxygen is a blue color liquid remaining in the fractionating column that can be separated like that, or else you can just allow that to go to the temperature of minus 183. As you are increasing the temperature increases at minus 183 degrees Celsius. What happens is the gas now, the oxygen liquid which is blue in color, that becomes gas, and that will be separated and is taken in different cylinders. Now, okay, children, this is how we'll conduct what is called a separation of gases from air by what is called fractional distillation. Now, each of these components they have a utility, children. Now, what are the uses of these three components? Not only these three, but there are a few others. Now, you know, well, we'll discuss the components of the three components like oxygen, argon, the nitrogen. They have their utility. They are separated by fractionation of the liquefied air, which is free from carbon dioxide, and also we have separated carbon dioxide. All of these four gases, they have some utility. So what is the utility of these? We will see now. Okay, children, let us see first the oxygen gas. Oxygen gas. What is oxygen gas? Okay, right. So it's called the breath of life. This is called breath of life. So it is the breath of life. So people, all animals, plants, everything, they live by what is called as oxygen. They breathe in oxygen, and this oxygen oxidizes the food material that is there in the cells, and that's called the respiration, and provides all the energy required to do various activities for animals. And where is this used again? So oxygen, it helps in burning. Okay, it's a gas which helps in combustion. If oxygen is not there, it's impossible for anything to ignite and also to burn, and it will not be combustible. So children, oxygen is necessary, right? Okay, so anything else, children? Yes. So this is how oxygen is a process. Oxygen is a gas which helps in various life processes. Okay, right, children. And what next? So it is also used for welding, then gas cutting. Okay, children, we have a gas called as acetylene and oxygen. When they burn together, they produce approximately 3300 degrees Celsius of temperature at the point where the flame comes, and that is able to cut very thick metals at that place. And also it is not only used for gas cutting, it's also used for welding purposes. Okay, that's good. This is about oxygen. Now what else? Where is this nitrogen gas used? Nitrogen gas, we think nitrogen gas is it's not that useful, but I'll tell you, children, if you see the percentage of oxygen, nitrogen and other gases, you see the nitrogen occupies the most percentage. What is the percentage of nitrogen gas in air? So it is approximately 78%. And what is the next one, children? By volume is that percentage. And the next, what is oxygen? Is approximately 20 percentage. That is nearly 21%. And the other gases like carbon dioxide, it occupies 0.04%, and the remaining argon and a few other inert gases, they become the remaining 0.9% of air by volume. So children, now what next? So what about this nitrogen? So why is this nitrogen there? What for is this? Okay, right, children, nitrogen, it is very important. This nitrogen, it combines with oxygen during the process of lightning and forms later on when rainwater comes, it forms nitrate. It falls down as some acidified water there. It's not very concentrated. Light acidified water with rainwater falls down as on the surface of water. Then the metals react with this what do you call the acidified water and forms nitrates, which are essential part of the food. Nitrates they add to become what are called proteins and the body materials of plants and animals. So children, so building block of plants and animals, the body material. Okay, you can say that nitrates. So for your information, peas, beans, all these things, they have nitrates, children. Also they have proteins which have a nitrogen in them. So nitrogen is essential because that becomes a part of our body too. All the muscle, they are all having nitrogen in case of in the form of proteins. Then next, children, we have where is nitrogen used? Nitrogen, if nitrogen had not been there, children, do you know what would have happened? So if oxygen's percentage had become more and everything, just a fraction, a small matchstick, if you just ignite it one place, the whole thing catches fire because the percentage of oxygen is more. So things can be under control. Who is controlling the process of combustion by oxygen? Children, it is nitrogen. So nitrogen is essential for controlling the combustion of things with the help of oxygen. So it's a regulator, I should say. in the atmosphere that God has provided. Right, next, what else does nitrogen do? Nitrogen, it is the essential component in what is called as preventing rancidity, or the odd smell that you get from the food if we keep it for some time. So storing food materials, that is done by filling the containers of those food materials with nitrogen gas. It provides what is called as inert atmosphere. Right, okay, children. And what else, children? Where is this nitrogen used? So, children, this is how nitrogen can also be used in your electric bulbs. Okay, electric bulbs. Okay, right, because that becomes that gives us a inert atmosphere. Apart from this, now, okay, we have a third gas, argon. This argon gas also can be used in electric bulbs, and that will give a beautiful color. And argon, nitrogen, these gases, they don't oxidize the filament. So the filament doesn't melt or burn away when the current passes. So children, at that very high temperature, the tungsten filament, if it meets oxygen, it will ignite, or otherwise it will get oxidized, and that will be broken, and you won't find any light. So children, in electric bulbs or incandescent lamps, we have what is called argon gas or nitrogen gas. Helium and other gases are used in order to provide what is called inert atmosphere to prevent oxygen from oxidizing that. Right, okay, so this is about nitrogen, argon, and we have seen oxygen gas. Right, what else? What have we understood? Right, now apart from this, we have separated carbon dioxide gas. Is carbon dioxide gas essential? Is it necessary? Yes, children. Plants, they breathe carbon dioxide and provide us what is called the carbohydrates. That's good. So we are not separating carbon dioxide and providing it for plants. No, not like that. But how is this solidified carbon dioxide used? Carbon dioxide, which is separated like this, that can be used, and this solid carbon dioxide which we are getting, that's called dry ice, and this can be filled in what are called cylinders under high pressure. And when these high pressurized cylinders from this gas carbon dioxide comes out and mixes in some sweetened water like cool drinks, what happens is the gas under very high pressure gets mixed into that sweetened water, and resulting in what is called as carbonated waters or aerated waters. And what do these do? So they are our general cool drinks and soda water. Right, okay, where else can this be used? So children, that can be used, dry ice or carbon dioxide gas can be used in fire extinguishers. Fire extinguishers, you know what fire extinguisher? Fire extinguish mean putting out fire. So any device which can put a fire, that's called a fire extinguisher. Right, okay, now how is this carbon dioxide used? So children, sometimes we don't need water. So in order to put out fires by electrical equipment, there we should not use water, right? And oil fires also can't be put out using water, because oil can float over water and continue to burn. And second thing is these electrical fires are dangerous, right? If you put water conducts electricity, so you may get a shock. So to avoid that also, we use what are called as carbon dioxide fire extinguishers. And these fire extinguishers, there the carbon dioxide, it comes out, gushes out with pressure, and when it goes over the fire, do you know what happens, children? It expands. When it expands, the property of carbon dioxide is it expands. Whenever it expands, it cools the atmosphere. So naturally, the ignition temperature of the fuel which is burning will decrease and results in preventing the fire. And it also forms a blanket preventing the oxygen from coming and oxidizing and aggravating the fire. So children, this is carbon dioxide's utility, children. So this is okay, aerated waters and also in fire extinguisher. So children, we have seen what is called as separation of the components of air and the utility of each of these components. Now, what are these components, children? They are all pure components. They are all pure components. There is nothing mixed in it. Nitrogen is a pure substance. Oxygen is a pure substance. Argon is a pure substance. And carbon dioxide, they were all mixed in air, and we were not able to use them individually. But when we have separated them, they can be used individually. So that's the main purpose of separation of mixtures. That's the idea behind employing separation of mixtures. That's very good. Now children, just before leaving, I want to tell you one thing. Where is oxygen further used? Oxygen is again a very essential part in scuba divers, the deep sea divers. They need oxygen. The mountaineers need oxygen. So they're all filled in cylinders and sent. And whereas children, that's in hospitals. That's very, very important. And so that supplies sufficient oxygen. See, children, when we breathe in certain quantity of air. So in that 21% of oxygen goes in. That will be sufficient maybe for us. But for people who are suffering with certain respiratory problems, they will not be, even that breath they will not be able to take. Or otherwise, even if they take, that will be sufficient for them. So what happens is that is hazardous for them. So to avoid that, they are supplied with pure oxygen. So that even a small breath that they take can supply enough oxygen, or more than that's enough oxygen for them, so that the respiratory function goes on. They continue to live and sustain and get strong. Children, thank you very much for this. So children, we have separated the components of air, and how children, that's been fractional distillation. And the next we have seen the utility of each of these components of air. Thank you very much.